This video is about my version of RobotHut's silent running drone. RobotHut is a YouTuber who builds a lot of mechanical, retro, 3D printed robots. I built a couple of them. This other one here is his claw walker design of the same robot. This is a pin walker. Uses one motor to drive these pins so that it moves it in a straight line. I wanted my version to be steerable and remote controlled with an infrared remote. So it has an Arduino and an infrared receiver and two motors so that it can be made to steer. In the video I'm going to show RobotHut's original version and my modifications or my version. It's just a simple demonstration. When you press the forward key on the remote, it walks forward. It'll walk until it's told to stop by hitting the enter key. To go backwards the other direction, stop. To steer it, you press one of the left to right direction buttons. By the way, this remote is set up for a Sony VCR and sending out 12-bit Sony codes. And the last direction. To go around the robot, most of the parts that you see are actually the original ones designed by RobotHut. These legs and feet, the pins are different or a different length. I had modified those. The front is the same. The back is the same. This midsection, I had to make extensive modifications to it. Originally it included a battery box and a lot of other stuff. I had to get rid of all that to make room for the internals. The inside, this blue part here, I had to redesign all that to hold the motors and the electronics and everything. All the silver parts on this were printed on a Ender 2 with Zytec PLA. The blue parts were printed on my original Folger Tech 2020 that I've had for about 3 years. This is the original pin walker design by RobotHut. I'll turn it on and you can watch it walk. There's an LED in the front. You can see the body rocking back and forth and the feet swivel to remain flat on the table. This is called a pin walker. The pins that refers to are right here. They're run by cranks inside the body. I'll show you that in a minute. I'll turn it on again. Those are what lift it off the table and push it forward, one leg at a time. Now I'll take it apart and show you what's inside of it. I have removed this front plate from the robot so that you can see the internal workings. I've replaced the plate with this blue one here that'll just hold everything in place. Behind this area right here is this Tamiya gearbox that runs on 3 volts. There are 2 AA batteries in this box right here. This is the cover for it. The motion is provided by 4 cams driven off the shaft of the gearbox. The 2 outside cams drive the pins up and down. They're located 180 degrees from one another. The 2 inside cams rock the body back and forth. Right here and right here. I'm going to turn it on so hopefully you'll be able to see that. complete, I'll show a robot with the body completely removed. Here's the Tamiya gearbox, the hexagonal output shaft of it. It drives the 4 cams, the outside cams, drive the pins up and down. The 2 inside cams run against these standoffs in the body to rock it back and forth. It fits on from the front like this. So this is what's in the steerable version that I designed. The power is provided by this 18650 cell with its charger board. It also bumps up the voltage to 5 volts, which really helps with the motors. They're rated at 6 volts and 30 RPM. We're a little on the slow side, so having extra voltage really helps to get the speed up. The power from the board comes into this little distribution bus right here. It just gives it's made of a piece of perf board or strip board, whatever you want to call it. It just gives a place to distribute the power to the Arduino and the motor controller board and wherever else you need it. This is the Arduino Pro Mini that provides the brains for the whole show. This is its programming header up here. The header is the only one that you solder to the Pro Mini. Everything else these headers would get in the way of the body. So you just have to solder your wires directly to the board. The motor driver is a L911OS dual H bridge driver. It looks like this when you get it. You have to remove the headers and these, whatever these are, connectors, because there's no room for that. You just need to solder your wires directly to the board. It is behind the Pro Mini in a sandwich type setup. Here it is right here. This is the main power switch. You need to keep a flexible cable for the power switch because it gets mounted on the body, which moves back and forth, and a stiff wire would break pretty fast. The other components are this TSOP IR receiver. I bought all of these parts from Banggood. The 2 micro switches, I believe, are referred to as mini micro switches with rollers. The roller is actually pretty important. You want it to roll smoothly on the cam. The motors are, like I said before, N20 gear motors, was rated at 30 RPM and 6 volts. They're a little slow. You could try 60 RPM motors, but I haven't yet. Let's start it up and see what happens. As you can see, when the power came on, it went through a startup procedure. This cam turned until it made the transition from a low spot on the cam to a high spot. This cam turned until it made the transition from a high spot to a low spot, so we're in opposite states. When the cam is high, or when the lobe on the cam is high, the pin is starting to go down. When the cam is on a low spot, the pin is starting to come up. To get the robot to walk and be steerable, we have to keep the 2 motors that drive the pins in sync with one another. If we just turned the motors on at the same time, they would quickly become out of sync, and the pins would be going down at the same time or up at the same time. It wouldn't walk correctly. To get the motors to stay in sync, what we'll do is monitor the state of each of these switches, and when one of them changes state, either from high to low or low to high, we'll assume that that motor is running faster than the other one. Stop that motor. Let the other motor continue running until that switch makes its transition from high to low or low to high. And then we'll start the other motor up again. then they should remain in sync. That's unless the remote is told to given a stop command or a change direction command. To get the robot to turn, we'll simply run the motors in opposite directions. It will turn in place either like this or like this. Let's power it up and put some remote commands into it. It's going through its startup procedure. Focus. Here's a reverse command, I believe. Stop. On the stop command, it waits till both makes for transition, so it stops in a known state. Now we'll go forward. Stop. Now we'll go left or right, I can't remember which. You can see it, one motor stopping and waiting on the other motor. They're running in opposite directions. The stop command, the opposite direction. Stop command. Now back to forward. Stop and reverse. The cams aren't perfect, and sometimes the transitions aren't exactly in the right spot, and it'll set up one side or the other a little, but it's okay for my purposes. Some of the assembly details before I put the main body back on. The legs are glued to the motor frame with Loctite super glue. These towers, which clamp the motors down, also hold this little bracket that the switch mounts to, and then that bracket is mounted to the tower. There are elongated slots that allow adjustment of the switch. The switch adjustment is pretty important. If it starts working erratically, it's probably because the switch is intermittent and is not close enough to a cam. That's usually a problem. The towers that hold the motor that's down, there are two of them. They are mirror images of one another. They have a little V, you can see that points to the front of a robot on each one. This clamp that holds the 18650 cell in also has a mount for the charging board that came with the power bank. This is just hot glued onto the clamp. It's held in by two 3mm screws, I believe. The mount for the Pro Mini, it looks like this. The Pro Mini eventually will be hot glued to this mount. I haven't done it yet. The power distribution is hot glued to this area. Behind that is the H-bridge board. Of course, all of these connectors have been removed so that it will fit. And behind that is this little spacer board. When all the connectors are moved, it'll fit like this. The screws will go through this and into holes in the main motor frame. You can't see any of that right now. This tilt cam, this is the only part I had to print with supports. That's why it looks so bad. One of the reasons it looks so bad. And it's held on with a 2mm by 12mm screw, I believe. You have to put this cam on after you assemble this cam and the pin it traps that pin in there. The cam that tilts the body drives, fits in a slot in the main body. The reason these are two colors is took me a while to get this part right, and I didn't want to print the whole body again, so I just made a little insert. The final STL that'll be on Thingiverse, this will all be one piece. As this cam rotates around, it pushes this up and down, and the pivot point is right there. You can see that's just snapped on. I have the main part of the body back on the robot so that I can show its rocking motion or tilting motion. I've replaced the front panel with this temporary panel so we can see inside of it. I'll turn it on now. It's going through its startup procedure. Now I'll give it some commands with the infrared remote. Stop and then reverse. Just a few notes on the way the robot is wired. On the way the battery and the charging board are wired to one another. The switch is hooked between the battery plus terminal and the B plus on the charging board. This means that to charge the battery through this USB connector, you'll have to have the power switch on. I haven't had any problems with that, even though the Arduino and the motors are all powered up. I don't drive it around when it's like that. But if you did have a problem with it charging like that, you could just disconnect it right here, the board from the power distribution circuit. The reason I did that is because these power banks seem to have a pretty high self-discharge rate, and every time I go to use one, it seems like it's dead. If you put a switch in between the battery and the charging board, you've defeated that problem. The switches for the cams are wired with both commons wired together and the common going to the ground on the power distribution bus. Each switch, the right and the left, the normally open terminal is wired to an input on the Arduino, one for right and one for left. The Arduino uses internal pull-ups, so there's no need for resistors to do the pull-up. The reason I didn't use headers on the Arduino is simply because there wasn't enough room. I just had to solder over wires directly to the Arduino. The wires from the motor driver board, you can see those coming up to each of a pair of outputs for driving on the left and right side. I'll put some pictures later in the video to show where these wires are connected to the charge board on the power bank board. It's kind of hard to show now. This is glued down. I've changed some of the wiring from earlier videos. I've replaced the soldered connections on the main power switch here and the infrared receiver here with DuPont connectors so that the body can be easily removed. This is the back of a robot. In the final version, it gets covered up with this plate and this door. The door will allow access to the charging board right here and the programming header.